Hey, all you AP chemistry nerds. Here's a problem I want to work with you guys. This is problem 16 from our reactions review. It's a combustion problem, it's a stoichiometry problem, and it's an empirical formula problem, right? It says cumene is a compound containing only carbon and hydrogen that is used in the production of acetone and phenol in the chemical industry. Combustion of 47.6 milligrams of cumene produces some carbon dioxide and 42.8 milligrams of water. The molar mass of cumene is between 115 and 125 grams per mole. Determine the empirical and molecular formulas. Well, there's a few things involved here. First, there's a chemical reaction happening, right? And that is a combustion reaction. Cumene, I don't know what the formula of it is, but it contains carbon and hydrogen. I'm going to say CXHY in some ratio that we're after. I want you to know that all hydrocarbons are combustible, and combustion involves the reaction with oxygen gas, and complete clean combustion produces carbon dioxide gas and water vapor. All right. All the carbon in cumene comes out as carbon dioxide. All the hydrogen in cumene has to come out in the water vapor. Oxygen, I'm assuming, is in excess. Some numbers that we know, milligrams. I'm going to ignore the milli. The same ratio if I stay in grams. So if we have 47.6 grams of cumene, we're going to get 42.8 grams of water. All right. Again, from the combustion reaction, I know all the hydrogen that's in cumene comes out in water. 42.8 is mostly oxygen, and part of it is hydrogen. I want to find out how much is hydrogen. I'm going to say 42.8 grams of water is what I collected. And because I know the formula for water and the relative masses of the elements in water, I can say that for every 18.0 grams of water, all right, grams of water comes down. I could say as a mole of water, and a mole of water contains 2 moles of hydrogen, and 1 mole of hydrogen is 1 gram. But in adding up that 18, I know that 2 of those grams were hydrogen, all right, individual pieces of hydrogen. So 42.8 times 2 divided by 18. I'm not going to be perfect with my sig figs here. I want to keep at least 3. It says 4.76 grams of that amount of water is hydrogen, all right? And that's really good to know because all that hydrogen came from the cumene, and if I want to know how much carbon is in there, I'm going to subtract my total mass of hydrocarbon, 47.6 grams of CXHY, and I've just determined that 4.76, eerily distinctive that it's 1/10 less. 47.6 minus 4.76 is 42.84 grams. That must be carbon. All right, 42 and 4 is going to be 47 grams of the compound. All right, I'm sorry, this is grams of hydrogen. And if I know grams of hydrogen and grams of carbon, I can find an empirical formula going on here in cumene. 4.76 grams of hydrogen. It's a diatomic element, but it's not an element, it's part of the compound here. And I'm going to use its relative mass for the atoms. 1 gram of hydrogen is 1 mole of hydrogen is 4.76 moles of hydrogen. Starting with my mass of carbon, 42.84 grams of carbon. Carbon's relative mass is 12.0 grams of carbon, is a mole of carbon. That comes from the periodic table. 42.84 divided by 12 is 3.57 moles of carbon. All right, so again, from my combustion, this element contains only carbon and hydrogen. The hydrogen came out in water. I found the mass of hydrogen in that water, subtracted that from the mass of the compound for grams of carbon, and my mass ratio of elements, I've now found a mole ratio. Well, atoms have to combine in small whole numbers. To make these whole numbers, I'm going to divide by the smallest number of moles. 3.57 divided by itself is 1 mole of carbon. 4.76 divided by 3.57. 4.76 divided by 3.57 comes out to 1.33333 repeating, all right, moles of hydrogen. So my carbon is in a 1 to 1 1/3 mole ratio with hydrogen. To make whole numbers, I'm going to multiply both of these to keep the same ratio by 3. 1 1/3 times 3 is 4. 1 times 3 is 3. I'm going to slide my paper up here. So my empirical formula is going to be C3H4. That's the simplest, smallest combining whole number ratio of elements in the compound. The molecular formula is always some whole number multiple of the empirical formula. All right? Its mass is between 115 and 125 grams per mole. When I look at how big C3H4 is, 12 times 3 is 36, plus 4 is 40, all right? Well, 40 plus 40 plus 40, if I take that ratio 3 times, that's 120. That's right in range of what I'm supposed to be, between 115 and 125. That tells me that the actual molecular formula is 3 times bigger in terms of carbon and in terms of hydrogen as the empirical formula. So my molecular formula will be C9. 3 times 3 is 9. 4 times 3 is 12, right? As an added bonus, all right, C9H12 cumene looks like this. Carbon, 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 carbon. A ring of 6 carbon atoms that is doubly bonded, all right, which exhibits resonance, and we'll go over that before too long. And on one of these carbons is another carbon with 2 CH3 groups on it. Every carbon likes to form 4 bonds. I would bore you if I added up electrons, but if you count there are 9 carbons, there are 12 hydrogens, and everyone has a full octet. This was just a bonus. You don't have to do this, all right? Hey, I'll see you in class. Peace out.